right, welcome back. In this example, r equals 32 over 3 plus 5 sine theta. We're asked to find what this conic section is without graphing it, and then see if we can plot it. Okay. So to do so, let's try putting it in the form r equals ek over 1 plus e sine theta. Okay. So to do that, first thing I notice is that there's a 3 here, and I want that to be a 1. So if I factor out that 3 is going to go upstairs then as a 1/3. So just a little bit of side work over here. I'm going to have this as 32, 3 over 1 plus. If I pull out a 3, I need to divide by 3. That's how I undo the multiplication there. And so you can see then that this is equivalent to 32 over 3. And this is going to be then 1 plus 5/3 sine theta. Okay, so there's my E. And E is equal to 5/3. So this implies then that K is equal to 32 over 5. Simply multiplying by, or dividing by 1 over E. So take the reciprocal. That's 32 over 3 times 3 over 5, which gives us the 32. So that's what K is. Our eccentricity is, I'll write that down somewhere, 5/3. Okay. So let's go ahead and figure out what this means. Well, it looks like then since E is 5/3, that this is that E is greater than 1, which means this is a hyperbola. Okay, so if R is between 0 and 1, then it's an ellipse. If it's equal to 1, it's a parabola. And if it's greater than 1, it's a hyperbola. So this is definitely a hyperbola. And let's see if we can graph it. I would recommend using GeoGebra. And if you plug it in, you're going to get something roughly that looks like a sketch like that. Plug it in, I recommend, and you'll see exactly what it looks like. But I hope that was helpful for this first one. All right, let's jump into the second example and see what that looks like. We have a pretty long problem. And it's not long in the difficult sense. It's long in the sense of like lots of things. So the curve is r equals 4 over 3 plus 2 sine of theta minus pi over 6. So we have a trig function that has an angle shift. Okay, so the first part is use the trig difference to rewrite the formula expression of 2 sine theta. Okay, so step 1 is to write 2 sine of theta minus pi over 6. So this is going to use the difference of angle formulas that we used, I think, in lesson 1, the one a day lesson 1. So sine, this is going to be sine of theta cosine pi over 6 minus sine pi over 6 cosine of theta. Let's see, so cosine of pi over 6 is square root of 3 over 2. This is 1/2. This is going to be 2 square root of 3 over 2 sine of theta minus 1/2 cosine theta. And if we multiply through by the 2, this becomes the square root of 3 sine theta minus cosine theta. Okay, so there's part 1. That's the first thing that we had to do. And now we want to eliminate the sine and cosine terms with y over r and x over r. So y over r, and this is step 2, and x over r. Okay, so what they're referring to there is the x equals r cosine theta and y equals r sine theta. Okay, so every sine theta will be a y over r, and every cosine theta will be so square root of 3 sine theta is going to give me a y minus, it looks like cosine theta, so it's going to be x over r. Right there. So that's going to give me an x for r. I put the r there. Okay. So there's that part. Okay. So that's part 2. And now we're going to take these results, and in step 3, we want to plug those back into the original value for r. Okay, in other words, this thing that we have up here. Okay, so to do that, we're going to get r is equal to 4 over 3 plus, now I've used the 2 blah, blah, blah already, so this is just going to be the square root of 3y over, oh, not square root of y, square root of 3y over r minus x over r. Okay, and then if I multiply top and bottom by r, then I will get that this is 4r over 3r plus square root of 3y minus x. Okay, so that simplifies that calculation a little bit. And we have an r on this side here, so notice that I can divide out r's on both sides there, which is the step 4. And so doing that then gives me that this is equal to 1 and that is equal to, so I have 1 is equal to 4 over 3r plus 3 square root of 3y minus x. Okay, so what I want to do then is multiply this whole term over to this 1. And if I do that, which is then step 5, okay, and what I'm going to have is 3r plus the square root of 3y minus x is equal to 4. Okay. All right. So I hope that that was clear. Step 3 was this. Step 4 was recognizing that you can divide an r from both sides. And then step 5, that leaves a 1 here. And step 5 was then saying take this denominator and clear out the fraction, multiply both sides by it, and get this result. Okay. So then going into step 6, I'm going to have to square that. So I need some room. I'm going to go ahead and erase this previous word to kind of give us some space up here. And I'll recopy this bottom part down up here. So we're on step 6. So this is 3r plus square root of 3y minus x equals 4. Very good. So it's said to square both sides in step 6. So if we do that, I'll do the right-hand side. That's easy. I'll let you guys handle the left-hand side. Oh, I wish it worked that way. So this is going to equal 16, the square of that. And squaring out this lovely mess, we're going to get, ooh, boy, it's going to be a lot. So it's going to be 16 plus 4x minus 4 square roots of 3y plus 4x plus an x squared minus square root of 3xy minus 4, oops, 4 square roots of 3y minus the square root of 3xy plus 3y squared equals 16. That just obviously flows right off the old multiplication hotline. That was a lot of fun keeping track of terms, and hopefully I didn't miss any. All right, now step 7 says to substitute r squared equals x squared plus y squared into and collect like terms in the form of the equation a x squared plus bxy plus cy squared plus dx plus ey equals, or no, plus f equals 0. Okay. So let's go ahead and do that. So this is the algebraically difficult part, I suppose. Okay, so if we plug in those in, we get 9x squared plus 9y squared equals 16 plus 8x minus 8 square roots of 3 y plus x squared minus 2. Oh, sorry. x squared plus 9y squared. 9x squared plus 9y squared equals 16 plus 8x minus 8 square roots of 3 y plus x squared minus 2 square roots of 3xy plus 3y squared. Okay. And now, let's see, we can simplify things, canceling things out on both sides. We get that this becomes 8x squared plus 6y squared minus 8x next, plus 8 square roots of 3 y plus 2 square roots of 3 x y minus 16 equals 0. All right, so identifying here is A, there is C, negative 8x, that is, this is D, that looks like that is E, looks like that is B, and there is F. Okay, all right, so we've identified each of those terms. And calculate the angle between the axes has been rotated. All right, so in step, okay, so this is step 8 to calculate the axes, the angle, then a cotangent of 2 theta is equal to A minus C over B. So we have 8 minus 6 over 2 square roots of 3 equals 1 over the square root of 3, which implies that theta is equal to pi over 6, which should look familiar as the angle that we saw. Question 9 then asks, what is the significance of the pi over 6? So the pi over 6 is the counterclockwise rotation of the axes. So this is some conic section that's who, if it were plotted without a rotation, you wouldn't see these cross terms, these xy terms. So one indicator, or one thing that you'll notice as you kind of do a couple of these problems, is that with conic sections, whenever you have cross terms, that means that it's some conic that has been rotated by some amount. And so this amount that this one's been rotated is pi over 6, counterclockwise, so in the positive direction. So that's what that term in the original equation meant. And let's plot both of these and confirm that this is indeed what we expected. So we're going to jump over to the technology now to complete step